Okay, I gave you this list of significant digits. You can find it online. This actually isn't in your book. They give you a little description in your book, but I didn't feel like it was enough. Okay, so significant digits, okay, all non-zero digits are significant. If somebody asked how many significant digits this has, it has one, 4. This one has 2 significant digits, 1 and 3. This one has 7 significant digits. Okay, so if they're not zero, they're significant. The zeros are the issue. Zeros between significant digits are significant. So this is 3 significant digits. This has 4. This has 5 because the zeros are in between significant digits. Okay. Zeros to the right of the decimal point and to the right of a non-zero digit are significant. This is the part that gets me a little confused. I'm not going to lie. I have to think about significant digits every time. This one has 2 significant digits. This 0 is not significant, but these 2 are. Okay. The leading 0 is not significant, but this one is to the right of the decimal point and to the right of a non-zero digit. This one only has 2 significant digits. Okay, the 1 and the 0. Okay, these that are to the right of the decimal point, they're not to the right of a non-zero digit. It has to be, notice the word and, it's not or, it's and. So this one only has 2 significant digits. This one has 3. How about this one? 2 significant digits. Because this 0 is not to the right of the decimal point. The decimal point is here. It's to the left of the decimal point. Okay, this one has 6. 1, 2, 3, 4, 5, 6. All of them are significant. All 3 of these zeros are to the right of the decimal point and the right of a non-zero number. Okay. Okay. So anyway, hopefully that helps a little bit. Oh, I missed that. Okay, the 2 zeros in front of the decimal point are significant, or to the right of the decimal point are significant because they are to the right of the decimal point and to the right of the number 4. Okay? All righty. You can refer back to this at any time. All right. So to perform calculations with measured numbers, start by identifying the number with the least number of significant digits. Okay? So your final answer is going to have the same number of significant digits as this number. All right? Your answer is no more accurate than the least accurate number given to you or in your calculations. Okay, does that make sense? All right, so this has 3 significant digits. This has 3 significant digits. So my answer is just going to have 3 significant digits. Okay, I don't have to say, they don't say round to the nearest whatever. Okay, they just expect you to know, okay, I'll just count up the significant digits and that's, that's what I'll have. So we're going to try to solve this triangle, okay? Solve the right triangle. What that means is find every degree measure, find every side. Okay, we've done these before in geometry. It gives us a little chance to do them again. There's so many ways. I don't even know where to start. I basically would find angle B first. That's just me. You don't have to. But once I know this is 90, this is 34 degrees, 30 minutes, I can find this, right? I know these two have to add up to 90. So I'm just going to take 90 degrees, which I'm going to make 89 degrees, 60 minutes. So that I can subtract 34 degrees, 30 minutes from it. Okay, so I get 55 degrees, 30 minutes for angle B. Okay, is that all right? I would do that first. They might not, it's up to you. Now I have angle B. So now I have all my angles. I have angle A, I have angle B. I know I'm a 90-degree angle. To find side B, I would probably take the cosine of 34 degrees, 30 minutes. the cosine equals adjacent over hypotenuse. So all I have to do is take on my calculator 12.7 times the cosine of 34 degrees, 30 minutes. Okay, so let's do that. Okay, I'll just make sure, as usual, see if I don't mess this up this time. My mode, am I in degrees? Yay! I didn't actually go the whole way out of this time. So I have 12.7 times the cosine of 34 degrees, 30 minutes. And we were hitting second angle and go into the minutes then. Okay, so it looks like side B, I get this big long answer, right? It didn't tell me what to round to. However, since I can only use 3 significant digits, I'm going to round this to 10.5. Does that make sense? 3 significant digits. Okay. 10.5 inches, I guess this is. Okay, so now I have B. The only one left is A. I think I'm going to just keep going with this angle and say this time the sine of 34 degrees, 30 minutes is opposite over 12.7. So I would take 12.7 times the sine of 34 degrees, 30 minutes, and I would get my answer. I'll do that in my calculator, and I round to 7.19. Okay, you do that in your calculator and see if you get that answer. Okay. Some people, once they get side B, they use the Pythagorean theorem to find side A. They would have been like 10.5 squared plus A squared equals 12.7 squared. That's fine. Okay, you're going to get the same answer. Some people might have used the 55 degree 30 minute angle and said, I'm going to use cosine of 55 degrees 30 minutes equals A over 12.7. You know, it's completely, there's so many different ways to do this. All right, so I'm anxious to see, just as long as you get these answers that I got, then you're fine. Okay, they do caution not to round off too early. Okay, like, in other words, I don't want to round what the sine of 34 degrees 30 minutes is if I'm writing that down. Some people write, they take the cosine of 34 30 minutes, they write that number here. Don't round until the very end. That way you have the closest answer. You might round too early and get some more round off error than you should. Okay, why don't you try this one on your own? Go ahead and pause me. I'm going to pause myself here. Okay, it's a little different now. I don't have any angles, do I? Maybe I will. Never mind. I'll go through this with you. I forgot this was a different one. No angles. Okay, I'd like to find angle A. I know that the sine of A is 29.43 over 53.58. Oh, so I guess I'm using 4 significant digits this time. All right, we did practice in 2-3 that if I want to know what the angle is, I have to take the inverse sine of this, right? That's what I'm going to do. Now, what I was saying about the rounding off, if I would go ahead and take 29.43 and divide it by 53.58 and maybe round that to 0.5493 and then take the inverse sine of that. Maybe I decide, okay, I'm going to take the inverse sine of 0.5493. Okay, then I'm going to get 33.32 degrees. Okay, I'm going to round up. So that might be okay. What I'm saying is you really should take, you really shouldn't do that. You should take the inverse sign of that whole thing. 0.54, don't round off. 0.549, don't round off till your answer. 927, don't round off here. We're not saying you have to round each part off. You have to round your answer. And I still would have gotten 33.32, as you see. But this might change. What if if this would have been a 4? It might be different. Then I would have just rounded to 33.31. Okay, I'm just saying you get a little bit more round off error. Be careful. I actually would have just done this. I would have gone sine inverse and I would have typed this in 29.43. I wouldn't have actually found that answer because then I know I have the exact decimal. I would have been like, what's the sine inverse of that? Of course, we do get that. Pretty close. I still would have gotten 33.32. Either way we put it, since we are rounding to four decimals. Okay, here's the difference between angle of elevation and the angle of depression. I know you've seen these before, but the angle of depression is the negative angle coming from the horizontal. Okay, so we're going to have some real life applications. You're going to need to draw a sketch, label where everything is, label the quantity to be found. Use the sketch to write the equations you need. You don't know, am I going to need tangent? Am I going to need sine, cosine? You'll know it from the sketch, and then solve the equation. Okay? So I drew this. Pat Porterfield knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top is 26 degrees 40 minutes. Her eyes are 5.3 feet above the ground. All right. She knows how tall she is, but then she knows, she took it from her eyes. So we want to know the height of the flagpole. So I drew that. I'm 123 feet back. Here's my angle of elevation, etc. So I think I'm going to use tangent because I need the opposite side. I need the height of the flagpole. And that opposite over adjacent would give me that, right? Whoops. Oh, I thought I did the problem. Okay, so I am going to say that the tangent of 26 degrees 40 minutes should equal opposite over adjacent. So if I take 123 times the tangent of 26 degrees 40 minutes, I should get it. That would be what A equals. Sure, when you do this on your calculator, you get what I get, okay? So that you know you're using your calculator correctly. Now that's A. They want the height of the flagpole, so I'm going to have to take 61.8 and add the 5.3 feet that were in her her length there, right? How tall she was. So if I say 7, so I'm actually 67.1 feet is how big the flagpole was. Okay, very similar with angle of depression. David observes a lighthouse that is 430 feet offshore. Okay, and he's at the top of a cliff. So we want this angle of depression. Well, looks like I'm going to use tangent again. I'm going to actually find this angle, which will be this angle, since I'm going with parallel lines here, right? Alternate interior angles. So that's a little trick there. The tangent of this angle is opposite over adjacent. Okay, so B is going to be the inverse tan of this. And when I do the inverse tan, let's see, how many significant digits? Just 2. So I'm just going to say 26 degrees. Now I did that on my calculator already. Please do that on your calculator and make sure you get the right answer. Okay. Oh, that's it. All right. Please, please, please. All right. That's the end of this video. Go forward with your homework. The homework assignment's on Schoology. If you have questions, come to my office hour. And I'll be talking to you soon. Have a great, be safe, be healthy. Bye-bye.